Hi everyone, this is Clayton, VE3IRR, and in this video I'm going to give you a quick overview of the software I've installed on the USB flash drive for the OARC Club Project. So when you first boot up your flash drive, you'll arrive at a desktop that looks like this. And the first thing to note is that if you bring your cursor down to the bottom of the screen, this launcher tray will appear with a bunch of icons for some of the programs we'll be using most frequently. And if you want to explore all the software that's on the USB drive, you can go up to the upper left-hand corner and click there, and you'll come to a menu with folders for all the pieces of software that are installed. Now let's go back down to the launcher tray here and have a look at the first program, which is GQRX. This is a multi-mode SDR receiver, and it's very similar to the SDR Sharp program that I showed off in the previous video. So to get started with this, you click on the Start button in the upper left-hand corner. And there we go. You can see right now we're tuning in a range of about 2 megahertz. You can see we're from 443.3 or so up to 445.3 megahertz. Now, first thing I'll show you is how to zoom in on the spectrum. Over here in the vertical axis, we'll probably want to zoom in because the dynamic range of the RTL SDR tuner we're using is nowhere near the 120 dB range that's shown here. So if you bring your cursor over to the left-hand axis, it will turn from an arrow into a hand. And then to zoom in, if you're using a mouse, you can use the scroll wheel to scroll up or down. And if you're using a laptop with a touchpad, you can run your finger up the very right-hand side of the touchpad to do the same. So I'm just going to run my finger up the side of my touchpad here. I usually like to leave this so that it's 5 dB per division. And I'll just raise that up a little bit so we're at a nice even multiple of 5 everywhere. And so now you can see here our noise floor is somewhere around minus 70 dB relative to full scale. And we can see signals that are up to about minus 25 or minus 20 dB. And to select a frequency to tune to, you can click individual digits. If you click on the top half, the digit will go up. If you click in the bottom half, it'll go down. Or whichever digit is highlighted, you can just start typing there. So let's say we want to tune up to 867 megahertz. That's where the City of Ottawa's trunked radio system is. And you can see already we have a bunch of narrowband FM signals here. There's a digital transmission.
I don't know, no, it was Crim's call. Terry took it because Crim was tied up, and I called you, so it's gone through 3 of us. No idea if it's getting thrown over.
And there was a voice signal, narrowband FM. And you can see I have it squelching the signal so that if I tune to a place where there's no transmission, we don't hear it. If you want to adjust the squelch level, you can go over to the receiver options and adjust the number of dB higher or lower there. Now, one thing you'll want to do is correct for any inaccuracy in the oscillator in your dongle so that you'll get accurate frequency readouts. So the way I usually like to do that is to tune to the Global TV digital transmitter, which has a pilot tone at 470.309 megahertz. And let me just mute the audio there. I'm going to use the zoom functionality again. I'll put my cursor here on the frequency axis so that it turns into a hand, and I'll scroll up here to zoom in. And you can see here that we're tuned a little bit low right now. I've got my tuning set to 470.309, but that pilot tone is actually a little bit below where I'm tuned to. So if you go to the input controls and this frequency correction box, we can start tuning that up. And you can see the signal moving over into where it's supposed to be. And for my dongle, I need about 29 parts per million correction. And in your case, the value could be anywhere between minus 100 up to positive 100. So now that we're properly tuned, we should be able to tune in to other signals by frequency exactly. So let's try the weather radio frequency for Ottawa, which is 162.550 megahertz. And you can see it's right there, right dead center, and we're tuned to it. So I'll unmute my audio so we can hear that.
Kilometers per hour. Temperature steady near 0 for Sunday night. Partly cloudy. Wind west 20 kilometers per hour.
Now, of course, we could zoom out by scrolling down on the frequency bar again, but another way to do that is to go to the FFT settings tab here. And if you click on the R button under zoom, that puts it back to the regular zoom level. So now we're seeing the full 2 megahertz bandwidth of the dongle, and you can see the this weather radio signal is quite narrow by comparison. Now, just to demonstrate receiving another mode, we could try a wideband FM signal. Let's go down to CBC radio, which is at 91.5 megahertz. You can see that, of course, that's a much wider signal. I can't tune it in using a narrowband FM receive. But if I go over to my receiver options, I can select wideband FM stereo for the mode, and now it widens right out. We're listening to a much wider range of frequencies now. And I'll unmute the audio. Actually, the audio is a little bit quiet there, so I'll just turn up the audio gain here in the audio tab. And there we go, I'll just mute that again. Now, one other setting you may need to change, depending on how strong the signals are in your area, is the RF gain on the tuner. So if you go over to the input controls, you can see here's the LNA, that stands for low noise amplifier gain. And you can see if I set that low, the signals actually fade right out here because they're not strong enough. And if I bring that up, the signal level increases. And if I go too far, actually I'm not seeing it in this case, but if I had a lot of strong signals present and I set this too high, I would start to see them forming intermodulation products that I don't want. But in this case, it looks like I can go all the way to the maximum without any trouble. So that's a quick look at GQRX. Now I'll close this down for the time being, and let's take a look at a couple of the other pieces of software I've included. Next, I've included GRAirModes, which is a piece of software for tracking planes that are broadcasting their locations using ADS-B. And to get that fired up, we'll click on this airplane icon. And the one setting you need to change here, you need to set your input source to Osmocom, which is the driver for the RTL SDR tuner dongle that you're using. So I'll just give that a second to update. Once it switches to Osmocom, you can click Start, and we will start receiving packets. And you can see here, this number down here is telling us how many packets we're receiving from planes. If you click over here on Live Data, you'll see the raw information contained in those packets scrolling by. And if any planes happen to go by that are broadcasting their location, you will see the aircraft listed over here in this list. And anytime there's aircraft listed there, you can go to the map and follow them around. It looks like we're not receiving any at the moment. So I'll leave this program for now. We'll just hit stop and close it down. And let's go on to the next program. This is a decoder for receiving pagers that are using the Motorola Flex protocol. So to fire that up, we'll just click the icon and wait a few minutes for it to start operating. And for this receiver, we get this terminal that's going to actually show us the pages that are getting received. And so I'll just open that up a little bit bigger so we can see some more. And then over in this window, we have a waterfall showing us the pager band, in this case from 929 up to 930 megahertz. And one thing we need to do here is set this frequency correction to the correct value. And you'll remember for my dongle I needed to use a correction of 29 parts per million. So I'll just enter 29 there. And once I've done that, now you can see in this channel waterfall, I see a little pager transmission. It's right in the middle of the waterfall. If I wasn't tuned correctly, if I was too high or too low on this frequency correction, this signal would be shifted to the left or to the right. So you want to make sure your frequency correction is set so that all the signals that appear are right in the center. And now already looking over at the left, you can start to see some pages that were sent out to pagers. This column here is showing the frequency that it was transmitted on. This is showing the pager number that that page was sent to, then a page type. You have num for numeric pages. Some of them say TON for a tone, just means that the pager is supposed to beep. And then there's text pages that are this ALN. I'm not sure what that stands for, but you can see already here's a page that included a bunch of text. If you leave that running, eventually your screen will fill up with all sorts of interesting messages that are getting beamed out to pagers around the city. And once again, there's also a gain slider here in case you get any intermodulation happening because the signals are too strong. You can decrease that gain, or if the signals are not showing up very strongly on the waterfall, you can drag that to the right to increase the gain of your of the preamplifier in the RTL SDR dongle. And to shut that down, I'll just click on this terminal window and press Control-C. Now, the final piece of software that I'll show you today is called GNU Radio Companion. And this is a piece of software that sits in front of GNU Radio and lets you build up your own software-defined receivers just by dragging blocks onto the screen and connecting them up with arrows. And these arrows are showing the signal flow from one signal processing block to the next. And there's a bunch of examples that I have here set up and ready to go for you to start receiving things. The first one here is a receiver for FM-RDS. RDS is a data stream that FM broadcast radio stations are sending out. It usually indicates the name of the track that's currently playing, the name of the station, and so on. And there's a software package for GNU Radio that knows how to decode those transmissions. And so here's an example flow graph that's showing how to take the samples from the RTL SDR dongle and do a bunch of processing to actually get that data out. So to start a flow graph running in GNU Radio Companion, you just click this little gear icon here, and that executes it. And you can see already here we're tuned to 105.3 FM. Again, we have a gain setting here, which we can set higher or lower. I think I'm in a pretty weak signal environment here, so I'm just going to crank that up a little bit. And you can see now we're receiving the data stream associated with 105.3 FM. If I unmute my audio, you can see we can hear the audio as well. This is actually a stereo FM demodulator as well, so it can receive the stereo audio and the data stream that's associated with the channel. And so down here it's showing us the frequency, the type of channel, it's music, stereo, KISS FM, the current time is being broadcast, and the name of the song down here. And I'll put the audio back up a little bit here so we can hear it. And if I want to retune, I can just drag the slider here. Let's try 102.5. There, so there's another station, and we're getting all the data decoded. And actually, if you look down in the console box here, you can see the raw data being printed out as well. So if there's any data that's not displayed in this little box here, you'll be able to see it down here. Just mute the audio again here. There's actually a bunch of other tabs in here as well that are showing various stages of the demodulation process. So this is the baseband audio. You can see the station, this is the baseband RF. of the station we're tuned into. You can see the station here, our channel filter is excluding frequencies outside of the range we want to listen to. Here's what the demodulated signal looks like after we FM demodulate it. The mono signal is there in the first 15 kilohertz, then a stereo pilot tone, then there's the stereo separation signal there, and I think right here at about 57 kilohertz is where the RDS data stream is. And there's some other things here that show you those signals individually. There's the mono signal, there's the stereo separation signal before we've filtered out its alias. There's the pilot tone, there's the RDS signal, and actually if you click here, there's an RDS constellation. This is showing the RDS signal as a quadrature signal, and since it's using binary PSK, just like PSK31, you can actually see there's two different phases, one phase here and one phase 180 degrees away from that, and those are the two phases that are used to transmit 1 and 0 bits in the signal before they get decoded by the decoder. And then finally there's a waterfall here showing the entire demodulated FM signal. Again, the mono signal is there, stereo pilot, stereo signal, and here's the RDS signal over here at 57 kilohertz. So that's the RDS receiver. We'll just click the X button here to shut that down for the time being. And then there's two other receivers we have here that you can try out. This Elster receiver is for receiving power meters in the Ottawa area. And this is actually a piece of software I've been working on just because I was interested in understanding how the power meter mesh network works here in Ottawa. So if we start this up, again, I did that by clicking on the execute icon, which is this couple of gears. What we're looking at here is a waterfall view of 6 channels. It's actually it uses a frequency hopping scheme, and so it actually has 25 different channels that hydrometers are transmitting on. And the bandwidth of the RTL-SDR dongle is sufficient for us to listen to 6 out of those 25 channels. And it's using frequency shift keying for the transmissions, so you'll see 2 peaks associated with each transmission. So there's the first of the 6 channels we're listening to. There's the second one, those 2 peaks, third, fourth, fifth, and 6th channel. And this FFT is basically showing us what a signal analyzer or a spectrum analyzer would show. The blue line is showing us the current signal levels, and the green line is showing us the peak signal levels. Every once in a while you'll see the blue line popping up to where the green line is whenever a hydrometer in my area makes a transmission. And then if you look down here in the console, you can see the demodulated data that's being printed out. Some of the packets I don't know how to fully decode yet, and so I'm just printing out the raw data. But if it happens to be a packet that contains somebody's hydrometer reading, then I actually decode that out, so you can see the meter that has this number here was at 23,032 kilowatt hours, and the hourly readings for that meter are also printed. So let's go back to the receiver. I have a couple other tabs here that just show you other information. Here's a waterfall view of the same thing. Whenever a meter transmits, you can see a little dash here show up, and you can see them hopping around from frequency to frequency. This is a view just showing a single channel, and so there was a meter that just transmitted. And you can see here's a scope showing you that single channel, what it looks like when it gets demodulated, and whenever there's a transmission, you can see the signal get bigger, otherwise you're just seeing noise. And this is showing the actual 1 and 0 bits as they're getting demodulated. So we'll shut that down for now. And the last receiver I want to show you is for receiving the local DMR repeater, VA3RFT on 444.475 megahertz. Now, since this is a digital repeater, you wouldn't be able to receive it unless you have a Motorola handy talkie or some other receiver that'll do DMR. But fortunately, we can decode it in software. So I'll fire up this flow graph here. Now, since this is a narrowband signal we're receiving, you want to make sure you have your frequency correction set properly. So again, for my tuner, I need to set this to 29 parts per million. And actually, it looks like we're receiving some voice right now.
WAN side, so some loss of loss of either. I don't know is if I powered off the repeater and powered the repeater back on, if it would start working. So, but I don't have the ability to do that from here. So, just reboot the router, right back up again, working. So the way I do this is,
So there we go. Now, one thing you'll want to make sure of, just to make sure you have this frequency correction set correctly, you can take a look at where the signal is centered here. If I had this set too low or too high, then this bright green area would be a little bit too far to the left or too far to the right. You want to make sure that's right dead center by setting this frequency correction to the correct value. Otherwise, you'll have trouble decoding the audio. So that's the final example I want to show you today. There's also a PSK31 receiver, but I don't have a transmitter going right now, so we'll skip that for now. And I'll just mention a couple of other things that are also installed here. I also threw on GNOME Predict, which is a piece of software for predicting where satellites are going to be. And I've configured this already to have our receiving station here in Ottawa and to show us a number of amateur radio satellites. One thing you'll want to do when you fire this up is make sure you're using the latest orbital data for these satellites. So you can do that by going to the edit menu, update TLE from network, and it'll go ahead and download the latest information. You can see a nice table over here showing us when the next satellite passes are going to be. It looks like the FunCube 1 is going to be by in about 8 minutes 10 seconds, and then FO29 just a little bit after that is going to pop up over the horizon. And you can right click on these and actually show the details of the pass. So there's where the FunCube satellite is going to go over and exactly what times it'll be at those locations. So that's handy if you want to listen into some amateur radio satellites as they're going by. You can of course receive them using software like GQRX. So I'll close that down. One last piece of software on here is Baudline. This is a spectrum analysis tool that lets you visualize signals, and we'll be using that a little bit during the club project. So that's all I wanted to show you for now. Later on, we'll be going into a lot more detail on some of this software, and if there's particular interest, I might put up some videos showing particular receivers among these that you're more interested in. But we'll leave it at that for now. And so I'll say 73, everyone. Once again, this is Clayton, VE3IRR. Goodbye.